So first of all, thank you very much for inviting us to today's third Biopharm Scientific Annual Meeting. It's a pleasure for us being here today. And as you know, at Roche, we have a long history in biotech manufacturing. So we are very pleased today to share with you the experiences and challenges we have faced in our journey. Very briefly to ourselves, who we are. My name is Andrea Kurz. I'm working at Hoffmann La Roche, based in Basel, as a lead external advocacy for Europe, policy and advocacy. A little bit about my background. I have more than 20 years experience in the pharmaceutical industry, mainly in the biotech manufacturing industry, and held various positions in quality, compliance, and regulatory. I'm also a qualified GMP lead auditor with background in GMP regulations and pharma quality systems. By education, I'm a pharmacist and graduated at the University in Heidelberg. Now I'm handing over to my colleague Dominic to introduce himself.
Also, a warm hello from myself. I'm Dominic Oehler. I'm a site compliance manager, also based in Basel and working for Hoffmann La Roche. I have 10 years experience in the pharmaceutical industry, all of the 10 years in biotech manufacturing, as a production engineer, as a quality manager, and now as a compliance manager. And I had the chance to build some knowledge in biotech manufacturing and also the general zone concept requirements for biotech facilities. And I'm holding a Bachelor Professional of Chemical Production and Management, and I graduated at the IHK Hochrhein-Bodensee in Germany. Okay. So what we want to present to you now is, let's say, the challenges and also the experience we made with biotech manufacturing, and we will go briefly view the difference from small molecules to large molecules seen from a manufacturing step perspective. And then Andrea will guide you through the, let's say, valid or important regulations and guidelines existing in the world and also applied at Roche. After that, we will have a brief excursus in the manufacturing controls we apply at Roche. What are the points to look at, where to focus on, and what is also then the difference again between small molecules and large molecules without being any judgmental or devaluing one or the other. It's just different. And yeah, so I think we can start from there. So as I said, we will have a brief look over the differences in the manufacturing steps. So we can go to the next slide. What we have here is really the, let's say, two typical process flows of a small molecule and a large molecule on the right side. And let's say there are small differences. Of course, based on the equipment side and also just by the nature of the product. For small molecules, we have normally the charging of raw materials and solvents, mixing, the chemical reaction, and after that, the separation and purification of the product. And as the product is normally a solid material, or it's a liquid during manufacturing, and after that it's dried, delamped, sieved, unloaded, and packed as a drug product or API. On the large molecule side, we have a master cell bank and a working cell bank at the beginning. So let's say a cell bank with the starting material, the adapted or modified cell line. And after that, we have at the manufacturing center, the media and buffer prep, cell culture, harvest, separation and purification of the monoclonal antibody, the API freezing, and then the sterile filling at the drug product side. And all of that, we have to say that downstream, the process flows, the GMP requirements increase as it is shown with the arrow in blue. Yeah. Go to the next slide. As I said, both processes, so small molecule and large molecule, have a difference in the nature of the product. A small molecule is a chemically synthesized molecule. On the other hand, a large molecule is a biologically synthesized molecule. And normally the product is a monoclonal antibody deriving from a genetically modified CHO cell or cell line. And then we can go on with the differences in the dosage form and the application. A small molecule is normally non-sterile, a non-sterile solid mostly, and the patient takes it orally. So, and on the other hand, we have the sterile liquids for the large molecules, which are normally parenteral and then given directly into the body, for example, under the skin or into a muscle, depending on the individual medicine. And on the other hand, the small molecule passes the digestive system of the patient, and also the body's defense works as a guard automatically. Taking a look at the manufacturing conditions in small molecules, they are mostly growth inhibiting. So we don't have any promotive conditions. And on the other hand, a large molecule, due to the manufacturing conditions, we have a high probability of contamination because of the growth promoting conditions. Next slide, please. As I said, during small molecule, the risk of contamination is relatively low, seen from the perspective of microbial or viral contamination. We have harsh conditions, they are growth inhibiting, and solvents are used for manufacturing regularly, so there is no risk of having any microbial or viral load in the drug substance or product. On the other hand, a large molecule where the risk is high, we have growth promoting solutions as cell culture medium and absolutely the right temperature for any bacterial growth. And the organism itself enables viral proliferation. And we have also retrovirus-like particles within the cell culture due to the nature of the cells. And this is deriving in different protection objectives in the manufacturing. There's always, let's say, a primary protection objective and a secondary one. The primary one for small molecules would be the containment for employee and environment protection due to the used solvents and also the starting materials and raw materials, and maybe also the dust, which is within the area, maybe during drug product manufacturing. And on the other hand, the large molecule, there is the goal to prevent the contamination of the product, especially during cell culture and also more or less during the whole process. There's always the risk of having microbial or viral contamination. And of course, there's also the goal of having the containment for the employee and environment protection. However, this is, based on our experience, one of the differences between small and large molecules, that the focus is a bit different. Okay, next slide. And then I would hand over to Andrea to give you a quick insight on the regulations and guidelines.
Yeah, before we go in further details on the manufacturing controls, I want to zoom out a bit and give you an overview on the international regulations and guidelines, specifically for biotech manufacturing. And as you all know, there is the ICH Q7, so the Good Manufacturing Practice Guide for APIs. This includes in the scope all APIs, so chemical and biotechnology, but it also includes a specific section on cell culture and fermentation-based APIs, which you can see here. And the World Health Organization has also issued a good manufacturing practice guide for biological products, which you can see here. This is the Annex 2 TRS number 999. And this guide is considered to complement the general GMP recommendations from the WHO guides. And its intent is to serve as a basis to establish national guidelines for GMPs, specifically for the biological products. This guide applies to the manufacture, control, and testing of biological products for human use. And this is from the starting materials and preparations down to the finished product. You'll see a small footnote here. This document is also published as the Annex 3 guide in the TRS report 996, but it's the same guide. And then when we look at the PICS guidances, so PICS has issued a specific guide for the manufacture of biological medicinal substances and products for human use. This is the so-called Annex 2B. And PICS is stating the methods that are employed in the manufacture of biological APIs are really critical to shape the appropriate control, the regulatory controls. So the biologics, in other words, can be defined largely by reference to their manufacturing methods. So the parts A and B of this guide contain guidance to manufacturer of APIs and medicinal products, specifically to biotech, and some further specific guidances. For your information, you can see also here the respective European guidelines in the Ultralex GMP guide. The Ultralex Part 2 is basically identical with the ICHQ7. So here we have I would say, a large international alignment of the regulations. And as I said before, the Part 2 is applicable to APIs, whether they are chemical or biologics. But also the EU has issued an Annex 2 specifically to the manufacture of biological active substances and medicinal products. And when you look into this one, you see it's identical with the PICS. So again, here, a large international harmonization with regards to good manufacturing practice requirements for biologics. Here we put some citations from the guidances. I won't read everything. The message the regulators put in these guidances is that, and I start with the bottom one, that the manufacture of biological APIs involves certain specific considerations coming from the nature of the product and the process. So the way they are manufactured and controlled makes some really particular precautions necessary. And unlike conventional medicinal products, which are manufactured using chemical and physical treatments, which result then in a high degree of consistency, the manufacture of biological APIs and products involves biological processes and materials. And this is, for example, cultivation of cells or extraction from living organisms. So the biological process may display variability. So also the range and the nature of byproducts may vary here. And this you can find this citation in the PICS Annex 2B principle part. And very briefly on premises and equipment before I hand over to Dominic. The Ultralex states that the manufacturing and storage facilities, but also processes and the environmental classifications should be designed to prevent extraneous contamination of a product. And the prevention of contamination is more appropriate than detection and removal. Also, contamination is likely to become evident during processes such as fermentation and cell culture. And we've seen this before in Dominic's slide because of the nature of the process. And with that, I hand over to Dominic to give you further information about the manufacturing controls.
Yes, thank you. And I think what we have summarized on the next slides are some manufacturing controls we apply and also the regulations explicitly ask for. So for example, we have liquid and gas filtration during the whole process. So we have 0.1 or 0.2 micron filtration using sterilizing grade filters for bioburden reduction. Those filters have to be tested depending on where they are used in the process, pre-use and after use for integrity, so that we can rely on the filtration process of those filters. We also have an quite wide or quite large range for microbial and contamination control. For example, bioburden and endotoxin testing. This is applied for raw material, for the environment, for product intermediates, and of course the final product and the final API. So also very important is the design of the processes and also the equipment. Due to the high risk of contamination, the processes are or must be closed or functionally closed. And of course, if you use stainless steel equipment, the equipment needs to be chemically or sanitized or receive a steam treatment prior to use. And on the other hand, you can use closed systems, for example, single-use systems. Coming to the next step, and this is also maybe a very big topic in biological manufacturing, is the validation chapter. It is very essential in several areas. For example, for the validation of chemical and microbial hold times of each let's say pool during manufacturing or intermediate product. It is important for virus reduction during manufacturing, and also of course for cleaning, sterilization and sanitization of the process equipment. On the other hand, we have aseptic handling during open cell culture processing. So it's very rare in the process due to the high risk when working in an open manner. Yeah, this is also a very important topic, that this is done in the right environment and also by trained personnel. As I already said, the validation of virus reduction needs to be validated. And of course, there's also a virus reduction filtration in the process, and other virus reduction steps like chromatography steps, which are validated for their virus removal load, or for their virus removal capacity. Now I spoke about validation. There's also the, on the other hand, the qualification of the equipment. It's a very important point here in the process, and also the let's say establishment of the manufacturing facility. Everything needs to be qualified. Everything needs to be suitable for biotech manufacturing, and it's on this hand really sometimes a different to small molecules. We'll come back to that later. So next slide, please. So now we're coming to the manufacturing controls we see in premises and equipment. We have, of course, one big topic is the HVAC system, so the ventilation and cooling system for the manufacturing area, as we have a closed, more or less closed manufacturing area, which also, of course, needs to be qualified and continuously monitored with the environmental monitoring for viable and non-viable particles. And we have the preventive maintenance, for example, of the HVAC system, where we make sure that the air supply for the manufacturing area is corresponding to the necessary requirements or the regulations. So it's more or less now let's say the premises need to be suitable, of course. We need to have airlock systems to really separate the outer areas. So, for example, the non-GMP areas from the GMP areas, to ensure or to also reduce the risk of microbial or viral contamination. We have such airlock systems to prevent the airflow into those GMP zones, and this is required for personnel and material. And in best case, those airlock systems are unidirectional to prevent any recontamination during the material or personnel flow. Same as for the airlock systems is for the flow of personnel and material itself. Even if in the manufacturing, let's say on the manufacturing floor, you have to be careful when designing the processes and also which equipment is located, so that the flow of personnel and material does not, let's say, introduce a new risk of contamination or recontamination during your manufacturing process. And of course, regular cleaning and disinfection of the floor, the ceiling, and the surfaces. For example, in our manufacturing site in Basel, there is a cleaning of the floor twice a week, and also the surfaces are cleaned weekly. We're using isopropanol, just to give you a quick idea of the effort. And also the whole layout of the area is designed with pressure cascades to prevent, again, the contamination of the area. So in the core of the process, so let's say the most sensible process steps, we have the highest pressure in the manufacturing area, and we are pushing the air to the non-GMP areas, in the direction of the non-GMP areas, to prevent any, let's say, contamination in the air coming to the open process, for example. So we can go to the next slide. So now a quick comparison on the gowning used in our drug substance manufacturing. You can see on the top the large molecule one. And I will go briefly through the introductions. There's absolutely no jewelry allowed. You have to wear safety glasses or safety goggles. No hair is allowed to be, should be, let's say, exposed to the environment. You have to wear a beard cover if required. Of course, the hair cover needs to also cover the ears. And all snaps on the clothing needs to be closed. The shirt needs to be tucked into the trousers. And all the skin must be covered at the ankles of the foot. And of course, you are wearing clean room shoes. So there's really a high effort every time you want to enter a clean room area. So, and more or less this is shown. So this ISO 9 area is the, let's say, less controlled area, coming to the ISO 8 area, where we have, for example, downstream or open filter installation. It's just based on what we see for ISO 9 plus a complete overall, so an additional overall, which is put on in an additional personal airlock to further increase the safety level for contamination prevention. Then the next step in our manufacturing is the ISO 5. And this is normally only used in seed laboratories, so where we handle open cell culture. And then there you have to add sterile gloves, sterile arm sleeves, and mouth protection. And depending on the level of risk, you also have to wear additional hairnet and also overshoes. If we take a look at the small molecule side, you can see it's a bit different. And again, this is out without being judgmental or devaluing anything. It's just the product has a different nature. And you can see that the personnel is just wearing, let's say, a pair of trousers and a shirt, and also, of course, safety shoes, but no clean room gowning. So the person is allowed to walk on the area and maybe going to the canteen using this clothing too. So it's a bit different here. That would never be allowed in biotech manufacturing. The next picture shows that the operator here is wearing additional gloves, also mouth protection, a hairnet, and overshoes. This is used when opening, for example, raw materials or charging raw materials, so that we protect somehow the product and also the operator. And the next picture, where you can see really the let's say maximum protection in clothing. This is really just operator protection when working with, for example, toxic raw materials or starting materials. So go to the next slide. And this is also then, I think, a bit the additional point. It's, as I said, the manufacturing requires, it's a biotech manufacturing, and it requires fundamental biotech knowledge for manufacturing and also comprehensive understanding for microbiology, for contamination control. It's, as you saw now, it's just different from a, let's say, the goal of protection is different, and it's really important to have the appropriate knowledge for that, and also the understanding where the risks are deriving from and what to take a close look on. Due to that, we have an intensive onboarding and training of employees. So our operators, or for example, internal or external craftsmen, need to also take a close look on hygiene, personal health, and gowning. It is important to understand for them that they are aware of the risks deriving from that.
Please, dear speakers, can you conclude the presentation? We must respect the time, please.
Also, very important is the risk management. Again, it's a bit a different perspective. On the other hand, it's to prevent thermal runaways. On the other hand, contamination, microbial or viral contamination. Go to the next slide. Or next slides. Now we have some pictures of premises in biotech manufacturing. You can see also the clean room areas and also the equipment used. And the difference, if we go to the next slide, so here we have some upstream pictures, and now this is downstream. Again, yeah, you can also see this difference in the ceilings compared to these pictures. You can go to the next one, Andrea. This is a small molecule manufacturing, and I think you can easily see the difference. It's from the clean room perspective, or the perspective of the premises. Yep. And then I think this is the last slide. We also have the differences in the materials of constructions. Again, coming from the nature of the product and the manufacturing processes themselves. Also that normally the piping of small molecule manufacturing is not really important where it is. But in biotech manufacturing, you want to reduce the amount of surfaces in the manufacturing area as much as possible to prevent contamination. And also the clean room classes used. We have ISO 8 or ISO 8.5 in drug product or packaging, and no clean rooms for drug substance manufacturing. And as I told you, in large molecule, we apply ISO 5, ISO 8, and ISO 9 for manufacturing with all the required or all the requirements described in the regulations. Yeah. To the next slide, there's also an interesting video on YouTube. If you want to look for it, you can just look for biotech production at Roche in Basel. There you can see more pictures and video of the biotech manufacturing in Basel. That's it. Thank you very much for your time.